So we're getting people streaming in.
Yep.
Let's wait a couple of minutes more. Apparently, we already got more people than signed up. That's unusual. We usually get less people than signed up. Shall wait until the number hits 30.
Well, I mean, 90 signed up, so.
Yeah. Yeah, but it's already 30, including us. So 28 attendees and us.
Okay. All right.
Wait a second. So Igor is saying that his audio isn't working, but it seems like it's his local problem. So yeah, Igor, if you can't hear. So all right. So our Q&A works like this, that we have collected a list of questions. So I'm not quite sure that we will be able to answer questions that come in Q&A, although I see one now. So we will go through the questions that we collected during the sign up. So Mats,
yeah, I think the intention is so hi, welcome. I think the idea is that I'm just gonna, we've had a series of questions, maybe 30, 40 questions that have come in through the webinar landing page. We've picked a few of those out that we think would be interesting to discuss. And basically I'm gonna answer questions, and Alexey, who's clearly spent more money on his setup than I have, is
but that's not going to work. So I can't allow you to disappear from the screen, and you have to answer questions as well.
Right. Okay. So I will try and answer questions as well, but we will see how it goes. Yeah, I guess we will just dive straight into it. And if any questions come up as we are talking, I will try and pick those up, and we'll talk about those as well if we can. So let's pick one of the first questions. Now, quite a few of these we've kind of grouped into categories. So a lot of people, for example, as in with this first question, have asked about how they handle read models when doing updates. So to give an example of one of the questions which have been asked, this was by, I'm really going to apologize, so I'm not going to pronounce names because I'm really going to struggle with it. But the question is, if a requirement for front-end changes and I have to update my read models, how to handle them? Do I have to delete all my existing persisted read models and replay the events to create new models? Or are there other ways to handle these situations? Another question in a similar vein was, how do you configure continuous deployment? Do you always reply the entire history of events to read models, or do you create migration scripts on demand? So I think generally it would be useful to discuss how we handle deployments of new read models and changes in requirements to read models. So
yeah, I remember that there were quite a few questions about blue-green deployments as well. So we can put it in the same bucket because those things are kind of connected. We wanted to have a game, but unfortunately I couldn't make it work. So our plan was, as soon as some of us say it depends, we'll raise a counter. Another opportunity or another challenge was that someone needs to drink, and that's not what my glass is here, but it's empty. So I'm not going to drink. And I don't have a counter, so I can say it depends as many times as I want without being punished for that. Let's not waste any more time. It's a very good question because apparently I recently had a big discussion, so to say, with Greg on Twitter just a couple of days ago, and apparently one of the topics was replaying events and producing new read models when read models change, and there is so basically you have a choice to replay. So his position that you replay no matter what, and justification for this argument is basically that in most systems data doesn't move that massively. Like, you don't have a huge amount of updates that you need to replace to your projections in order to rebuild your read models. So therefore, it basically takes very time to do so. Here comes it depends, because in the industry I spent most of the time working, it's not exactly the case, because we have billions of events. And it might take a couple of weeks until we actually reproject them. So depending on the case, and depending on the industry and the business you're working with or working for, you need to choose by yourself. So let's discuss some of the strategies. First of all, replaying all the events. So how does it work? So here comes blue-green, and that's a nice part. And I like this really a lot, because, and we do agree with blue-green as well, even though we have millions and sometimes billions of events, because it just pays off well. So imagine that I found a big issue in my existing projection, and apparently my read models don't suit the case anymore. But I know that the existing read models serve the purpose, and there is an API that points to those read models. I usually tend to pack them together in some kind of one package. So it's the projection that builds read model in some kind of database, and the API on top of that, because the API needs to know about the structure of read models, basically the contract of a document or relation database, whatever you use. So when the projection changes, I mean, the contract changes, the persistence mechanism might change, and the API might need to change as well, because it needs to use the same persistence, same contracts to read from that store. So they go together. Okay, let's say we have a new projection contract, and we need to see if the API contract changes as well. If yes, then we can change all along and produce a new version of the API for the whole thing. Then we deploy them in parallel using a different URI, and or not using any URI. It depends. Sorry.
There it is.
On the what you want to do, because when you just deploy it and make it publicly available on different URI, what happens is they have no checkpoint. So they come along and say, okay, I'm going to build from scratch. They start from beginning of times, or whatever TTL or expiry date you have in your event store, and place them all along. You build new projection model, basic new read models in your projection store, and you have new API pointed to that. What you can do now is basically you can start testing it with real users using feature flagging, something like some advanced tools like Unleash. You can target them by country or whatever, switch some of the users to use new API, maybe even new UI, and use those new read models. And in time when you're happy, you basically say, I turn off the feature flag, the old part can die, and I use a new one. If you don't want to use any A/B testing, you basically don't publish them online, and you wait until it rebels, and then you publish the API and the old URI. But probably if you, since still you version your API, you might have different URI anyway. You might want to keep them for a while, both of them running, because not all the UIs might pick up the change immediately, and you might benefit from keeping the old one for a while until your metrics show you it's not used anymore. So
yeah, I mean, one of the other good things about this is that you can basically, if for some reason the new projection that you've introduced has got a problem with it, you can always switch back to the old one because it's still there as well, right?
Exactly. So if the API doesn't change, so it's only some internal to the projections, so probably it contains more data, it contains a bit more different structures. So for example, if you use our DBMS, you have different, more optimized query. I don't know, you build new indexes or whatever. You denormalize it in a different way. Then you just tell the API to now, instead of talking to that database, you talk to that database. Instead of talking to this document collection, talk to that document collection. You can do it automatically. You can basically replace the connection string sometimes and just restart it, and it will work. So, and remember that both of them running in parallel will be completely accurate at the same time. So let's see if what happens if you cannot tolerate the period, the gap that produced by a huge amount of events that you have. So if you have long streams, you probably already introduced snapshotting, so you keep your entity state in the parallel stream as a snapshot. You might start by reading its first available snapshot. So you read backwards from the stream. Well, it's a bit problematic because you need to read stream by stream. Probably it's never going to work. But it might, because you can just read all the snapshots first and build a piece of state somewhere back in time. And from that moment, you start reading all the events and ignoring events that you don't need. And it's, although the network traffic probably would be the same, you because you still receive all of the events, but you don't do any I/O in the database. So this is where the most time is spent anyway. So that could speed up your stuff. In the worst case, of course, is that you basically have no choice than saying, I trust my current read model, so I'm going to use that as the source of truth. So I migrate. That's a traditional database migration from one schema to another schema. This is a bit risky, and I would say, unless you absolutely must, I wouldn't do that. So as I said, a couple of months ago, rebuilt a projection on a store that has, I don't know, tens and hundreds of millions of events. I just let it run for 2 weeks, maybe 3, because the old one was still working. It wasn't that good. The main problem there was performance. And at the same time, we decided to change document structure since we touched the code. So let's do it. So I basically rewrote it. And here we go. Well, I like the fact that I can rewrite the whole thing from scratch because they are usually so small. Then it's just not a problem. One marginal case is every event represents the state change on its entirety. So basically every new state gets replaced. It's more like a state source, state sourcing. So basically you do the snapshot of your entity every time. It's not event sourcing anymore, but it could be valid if you just receive the sensor readings, for example. Each new one replace the old one. Then you don't need to do anything. You basically can just start from now. And if your sensors, for example, always sending the data, in the daytime, you will always have the actual thing. The last possible scenario that I can think of, but I'm sure there are more, is that if your projection is slightly different from the old one, for example, it needs one more field. What you could do is that you use the old one, but at the moment you need to, basically it's on reading. So you use the old contract, just one field or 2 fields missing. So at the moment you read and you discover that's missing, you get it from somewhere else.
Yeah.
Eventually they will all populate. So either by events or you can write at the same time, which is kind of nasty because you're supposed to be reading, not producing side effects. Maybe you shouldn't do that. But over time, you will not read anymore. And if you can set a metric on that and say number of that kind of extra reads, so in reachers, but not on the event sort of processing pipeline, but inside the projection query. If you see the readers are still reading, then you probably need to find out why. But that's why you need to measure. But if you see the number of reads are steadily decreasing, then you say I'm safe, so it's okay. Now this is what I can think of out of my head straight away, but I'm quite sure there are a couple more.
Yeah, I think 9 times out of 10, I generally have always gone for the whole blue-green idea.
Yeah, I like this, yeah.
It's simple. You can let it run in the background. You can test it with production data before any customer gets to see it. And you can be sure it's right. And the actual, as far as the customer is concerned, there's no migration for them. It's instantaneous for switch, even though it's taken weeks in the past to catch up.
Unless there is a UI component that actually has a dependency on how the projection is built, then you probably want to speed it up. So this is the only argument I could use to use something else. But again, the argument might play weak in terms of the complexity of all additional methods compared to this one.
Sure.
So yeah, and in my view, projections are perfect candidates for microservices. Probably the first thing that you can microservice of sorts. Just put it on the side, let it do your thing, and then build an API on top of that and keep it. And then when you don't need it anymore, you can even measure them. Like measure the number of reads. If you get lose control on your projections, somehow it can happen. You can measure them all still, and when the number of reads from that projection through the API comes to 0 or close to 0, consider deleting it. If you can even automatically delete it.
Yeah.
If nobody's using it, I'm deleting myself and my database. So boom, done. Because it's not source of truth, you don't really care.
Cool. All right, that was interesting to hear. Let's move on to another question then. This one's probably it depends on another bone of contention, which is around frameworks and libraries.
Ooh.
Yeah, so one of the questions asked was, it is recommended to not use any framework or library for event sourcing, but in reality, creating your own infrastructure code to support ES and Saga's process managers, that could be an argument in itself, ends up quite a lot of code. I'm still unclear as to what the best course of action is in this regard. And as somebody else has asked, assuming a team decides to not use any framework libraries for event sourcing, would you please shed some light on how to decide on synchronous versus asynchronous ES API they should go with? Not sure about it.
Start with the end, maybe.
Yeah, but the question in all is, yeah, there always seems to be this argument that, oh, it's simple, right? You should, once you get the concepts, it's easy to write your own library. And in actual fact, you can build a library around event sourcing and projections. It probably doesn't amount to more than a few hundred lines of code. It's not going to be production worthy, but it is possible to write one with a limited amount of code. But what's your take on using frameworks and libraries to build these applications?
Shall we start with sync versus async?
If you want to start with sync versus async, by all means go with it.
Yeah, because that's a very short answer. I mean,
okay.
There is no justification when you're doing I/O to use sync code, because basically that's not how you build things. If you have the ability to do I/O asynchronously, then you should do that. You unblock the threads and let the I/O do its thing by its own. So basically awaiting this. So yeah. Frameworks and libraries. Yeah, a friend of ours, Sergio, says cake is a lie. So he continuously produces a decent amount of critique towards people that use stages and conferences saying you don't need anything and just write your own stuff. It's always, and I had very interesting conversation basically yesterday with Chris and Dave and Zach about one of the topics, basically that, and we discussed the argument that Greg used. You don't need any event sourcing framework. Well, so look at this. So we have, for example, Axon. I don't want to criticize them. It's just not, I just want to use this as an example. Axon is highly opinionated, infrastructure dependent, and a commercialized framework. They earn money on building it and expanding its scope. So another example that I know is Bifrost, written here in Norway by people I know. And I know customers, companies of theirs that are using this framework. So, and I know engineers that use frameworks like that. Mm-hmm. So first of all, those frameworks are always opinionated towards how developers of this framework started up, what they knew about event sourcing, and what APIs they built for you to use. And on a later stage, just to figure out, because it's supported commercially provided framework, they can't just change the API well. And they have to support things as they are and make changes in a way that is not obtrusive in order to support customers that are using older versions who want to migrate to new versions.
Sure. And
therefore, they get quite a lot of limitations. They probably changed their mind how they could have built it from the start, but they can't change it drastically because of they have a lot of customers that are already using it. So Chris, for example, he wrote the framework, toolkit, library, whatever you call it, React to domain, and he likes it, and he says it's production ready, so just grab it and use it. But keep in mind that this is Chris' way and Chris's opinion how the event source applications have to be built.
Yeah.
So if you have a team that has zero knowledge about event sourcing and they just want to play around with something, I would say if you want to build a production system, that's probably a good idea to get something off the shelf and start using it.
Mm-hmm.
If you want to build up a team knowledge about how event sourcing work, you can spend a couple of weeks just doing that yourself. You might end up still buying or using open source free library or framework for that purpose that someone else is building, but you will gain a lot of insights of trying to do it yourself at the start.
Yeah.
So in our organization, we do have a massive framework that has been built, and we do have about 4 different versions. One I have built in 2015 myself, and I can say now that's a piece of crap. So would I like this framework to be a product that I would put on GitHub and be proud of that? Probably not. But it could have been a good chance that I've done this, and there'll be a lot of people using that, and I would still answer their questions on GitHub and try to fix those issues that I produced myself.
Yeah, I mean,
so
what I was going to say as well is, I mean, that's talking specifically about frameworks as well. I don't think there's any. I can't think of an argument against reaching out for libraries that accomplish certain tasks, such as Projac or aggregate source, you know, which kind of will help you along the way in building your own internal framework.
Yeah, what I've done, I basically took Projac and the aggregate source, and I used them as a basic things as a base, but I put a lot of artifact dependency injection, and I built a lot of different strange things, and my projections were actually represent aggregate states, and everything was around that. And I clearly know today that's under patent, so I wouldn't ever recommend anyone using that. But surprisingly enough, the application, the production system that's built using that framework is still in production, and there are happy customers using it. I'm not sure, I couldn't say about the same about developers that are using it. They're probably cursing me.
Yeah.
But yes, so
somebody
I could say one thing. I could say one thing, that production readiness is a different topic in its entirety. So production readiness for something that you build might involve pieces of infrastructure that only you use, or you use extensively, that the author or the group of people or the company who are building other framework might not even think about. So there is always a risk of getting coupled to something. At the same time, you might get support if you pay for it. Yeah, I would say, again, try it out. That's what I try to do in the book. Like, give some foundation that you can just grow from nothing up to some point that you can either decide, I'm comfortable and I can move it forward by myself. I say, okay, I understand how it works, so I can buy something and see if it fits my needs.
Yeah. Just as a final note on that, somebody's recommended EventFlow framework in the chat. I haven't used it myself personally. I don't know if you have, Alexey.
No.
I've seen it around, so yeah, that might be an option for people to look at. Let's try for another question. Okay, so this one's specifically about EventStoreDB, and actually it's been discussed internally recently. And the question, there was two questions on it. The first one is, I thought of implementing an adapter script to read events from the old store to push to the new EventStoreDB instance, but that loses the timestamp information. Is there a way to specify timestamps while appending events? And the second question was, since controlling the date of an event is so vital for instances for migration, why EventStoreDB does not have built-in support for this? Of course, there's a separate date field, not replacing the current one. Currently, one has to store metadata with every event for just that basic functionality. So the question here is around the fact that EventStoreDB has a timestamp on each event that's persisted to EventStore, and that's controlled and stamped internally. And when people are writing scripts to migrate from one database to another or some similar functionality, because it's controlled internally, that timestamp's lost. Now, there is developments. We are working on ways to better migrate data from one store to the other. For instance, such as geo-replication, and also with the cloud product coming out, the ability to migrate your instances to the cloud. But also, I'd argue that if a timestamp is important to you, then I would potentially consider taking control of that yourself and stamping each event, you know, with your own data, especially if it's specific to the domain.
Yeah, you can put plenty of information in metadata, so that's what it is for. At the same time, we learned over years that update the commands and events convey the information who performed the command and when. For many purposes. So, for example, if you keep the audit log of your commands and you have events in the store, they can easily find out what is the gap between receiving command or issuing command and event actually representing state mutation, and you can see how fast or slow your system is. And at the same time, it gives you, like, everyone loves event sourcing because it gives you the audit log. And I would say no audit log is complete without knowing who performed the state transition and when. So we always do something like added by and added when, updated by, updated when, deleted by, deleted when, as business information, not even metadata. Although I think in our framework current version, we do have it also in meta.
Mm-hmm. Yeah. So there is something coming that will help from migration and backup and restore instances. But yeah, if date's important to you, which it should be, then I think you need to start it yourself. The next question is just one sentence, but could open up a whole world of fun, which is why do people say event sourcing is complex?
Yeah, nice one.
Yeah.
I honestly know and don't know, because first time I encountered event sourcing many years ago, I thought it took me a while to even understand it, what it is, but it probably was due to lack of information, and now it's a different story. Everyone is talking about event sourcing, so that hard to figure out. I'd argue that anything you don't know, you haven't used before, is complex. For me, HTML is reasonably complex, and CSS is freaking complex. And Matt can confirm.
Yeah, I was going to say, I don't think that's just you. Well, I think everybody finds it.
Yeah. So, and some people just find it a piece of cake, although I never met one. But my wife is much better on CSS than me. So for her, the code that I write in C# is completely cryptic, whatever set of characters, but CSS is just fine. When I was writing a book and I was trying to do the aggregate persistence in entity framework, and a lot of people argue that it's pretty easy to use, I spent a couple of days figuring out how to persist simple value objects in the relational model, although I never had this problem because there is no impedance mismatch in event sourcing. I wasn't even care. How would I persist this bloody thing? So working with document databases is a different story, and working with relational databases is a different story. It's just that as soon as you get comfortable with something, you see it as a piece of cake. And I cannot read code with breaking flow. I'm much more fond of functional code with expressions, but some people find my code unreadable because of that. And when I see three nested for each loops, I just close the file and run away with horror. But some people say that's perfectly okay. Your select many don't make any sense to me. So it's very, it's not even opinionated. I don't see a discussion there. It's complex in terms of that you never done it. Then you need to figure it out, and then it will be okay.
Sure. Yeah,
there are concerns that you don't have with state-based systems that, for example, you persist your piece of state and you read it straight away. Most of the time you get what you wrote just now. If you work with RavenDB, probably it's not the case. But that's probably the most obvious concern. But for the rest, I don't know.
Yeah, I mean, for me, I think there are a number of mistakes that you can make starting off when you get into production, such as like double dispatch and things like that can cause issues. But I'm with Alexey on this, but it's like anything. It's complex when you first learn it. So, but I think once you get your head into it, it becomes quite simple and intuitive to write applications in this way.
Yeah, there is a comment from Kin Khan who's saying it might be more intimidating than complex. Yeah, I mean, if I would be trying to write F# code now, it would be probably quite intimidating experience for me and depressing. But if I am determined to be proficient in that, then after spending a week or two, probably it will be enough for me to feel comfortable. So,
yeah. Okay, so the next question, again, is about EventStoreDB specifically. And somebody's also mentioned about this in the chat, which is, well, one, when will the non-SSL version of EventStoreDB appear, and what about updated documentation to be released? So in regards to the non-SSL version, the 20.6.1 will come with a flag. Correct me if I'm wrong on this. It will come with the insecure flag, which will allow you to run it without SSL. So, and hopefully that will be coming in the next week or two. There's a couple of things left to tidy up on that before we push it out. And as regards to updated documentation, we've been working on it. Alexey's been working on it as well. We've realized that the actual documentation we have currently isn't the greatest. And we're in a position now pretty much where we can publish that documentation. It is by no means complete. There are still gaps, and there are still things we need to fill in around, especially particularly around the new features in 20.6. But we are working on it. And if anybody wants to actually go look at it, as long as they don't judge us too harshly for it at the moment, I'll post a link in chat. Is that safe to do, Alexey?
Yeah, definitely. Yeah, I was giving a link and discuss for quite a while.
All right. Okay. There you go.
I have to say that version 5 server documentation has improved a lot compared with the previous version. Versions 26 documentation, both on server and client side, is lacking, but its server side is basically almost non-existent. The clients, Matt was working on that, so there is code there, there is text there that you can use. In Secure and 26.1, the preview packages Docker container are available on GitHub. So if you just can, I think the examples that you use, Matt, in the client documentation are using 26.1, and the Docker Compose files uses this GitHub container registry. So if you just download or create Docker Compose file from the documentation and spin it up, it will run in secure mode.
Yeah. So just to give an idea,
you need to use the client, the preview NuGet package from the client as well.
Yeah. So just to give an idea of what our intentions behind developers.eventstore.com is basically we're going to try and maintain documentation for all supported versions of the server and all supported versions of the client. So, you know, as the clients progress and add more features, we'll just introduce those. We also want to try and start giving more guidance on how to actually build event-sourced applications and how to use EventStoreDB rather than just API reference material. And we're hopefully going to start working on that during the course of this year. So the hope is this is better than what we've got. I think it is, but there is still a bit of a way to go on that one. But by all means, take a look, and if you have any thoughts or comments, please let us know.
Yeah, we also the developers.eventstore.com would cover documentation for all the libraries that we produce ourselves.
Yeah.
So currently the Java library has been announced, and the JavaScript client library is in works. So we expect all of this to be available pretty soon.
Yeah, there's likely to be a Haskell and a Rust client pretty soon as well.
I'd say Go client probably comes first, no?
Potentially, but I think the Rust and the Haskell one are already in progress. But yes, the Go one would also be useful. Right, let's pick out another question. Let's have a look. Okay, so here's a question, and I've come across this one in the past as well, which is, in a pub sub-architecture, when a microservice subscribes to an event from another microservice, should the subscribing microservice A, emit the event and modify it internally to modify a materialized view? The event would not be stored in its own stream. Or B, transform the event it receives into an internal command, handle said command, and emit a new event and store it in its own stream.
Okay, so basically the question probably is, because I had a hard time to understand it, and you explained to me, Matt, yesterday. So the question is, basically, is a reaction on an event, should you change the state of your system, the context to your own, based on what you get, or you need to raise a command and handle the command as you would otherwise.
Yep, that's about right. Yeah.
Yeah. So the answer is, of course, it depends. We have, and it actually depends. So it very much depends on the context. The context might be that we have event streaming system. So the receiver of the event that comes from the outside has to record it. This isn't particularly common in integration scenarios, because what you do is basically in your, say you have the service A, I would call the microservice, whatever, macro giga service A, and your service B, and you work independently from them, but you need some data from them. And they basically tell you that our system transitions a state, and this is the pace of transition. This is what happened. So what you do, you record it as an anti-corruption layer in your own materialized view read model, and you use it. Instead of calling them every time you need some data from them, you call it, or you use your own storage. That's extremely common. That gives you a decent degree of isolation, and you don't have a temporal coupling with that service, because if they go down, you don't really care, because you have your own copy of the data they have. In a way you're comfortable working with. By no means, if you have an event that comes from the outside and you have to transition your state, the state of your subsystem, not the materialized view of another system, but your own system, I'd say probably you shouldn't use, you are not in another context. You're basically in the same context. Maybe you have another aggregate, you isolate it as a microservice, I don't know. So in a normal scenario, when something happened on the outside and you decide what to do, then I'd say most of the time use the command, because you probably already have command for this kind of state transition, and you have an entity, an aggregate that has a method that handles this. And here comes the situation when your system needs to protect its own integrity, no matter what happened outside. So you couldn't risk bringing your system into inconsistent state because someone told you so from the outside. You just can't do that, because you have your own environments that you have to protect. So your system must stay always consistent, and therefore you might say, I understand that you have done it, and I need to do something else, but I can't, because then I would be inconsistent. So in this case, you say, I'm not going to do that, and somehow you inform them, or you inform someone else of the situation. So, and then you might choose, you say internal command, you just sort of, what's it called? Use a mediator pattern. So you call the command internally in process, but it's still a command. The act of reading the aggregate or entity from a store, applying, asking it to change its states to execute its behavior and produce an event that represents state transition in your subsystem, is basically executing command, even though you probably don't publish or send a command on the bus or message broker or whatever. You're still executing command, because the result of that could be, no, I can't do that.
Yeah.
So for integration, building sort of materialized view of another system based on their events is perfectly fine. You basically can't say no to that, because they say, I changed that field, or I changed that name, or whatever, this customer's merged on this user stopped being a user. You have to reflect this. You don't have to say something about it, because you have no say, and that's their business. But if it concerns your system and your environment, your system state, then you have to go with commands. Doesn't matter how it's implemented technically.
Yeah, I think in the past when I've spoke to people about this distinction between the two options, it's often come down to trying to take one specific approach in all cases, and that just doesn't work.
No,
ever. I think I'm going to say it depends. But yeah, I think that pretty much covers that question. I might come back to that one. It's the Kafka question.
Oh, I love this one.
Do you want to do the Kafka question now?
Yeah, do Kafka question now.
Okay,
No
let's do
problem.
the Kafka question. So is it something that comes up almost on a daily basis for us, in one shape or form? And there's been 3 questions around this. There might have been more, so the questions were: do you think Kafka can replace Event Store as the event database in an event-sourced application? Asking just because Kafka seems to be so popular. Another question was: what's the difference between Kafka and EventStoreDB? And then finally, how are the Event Store products positioned compared to other event-driven tools like Apache Kafka and Spark, Azure Grid, Data Factory, RabbitMQ, and then Service Bus? And why should I choose for Event Store? Why should I choose Event Store over the alternatives? Well, I mean, EventStoreDB is, as it's been renamed, it's a database specifically built for storing events for event source applications. RabbitMQ is it's a message queue, and Service Bus is a library that sits on top of many transport protocols. They're just not really comparable in that regard. EventStoreDB does have some message-like functionality in that you can subscribe to streams and publish to multiple consumers, but ultimately it is a database and not a message queue. Kafka, comparing it to Kafka, I think I'm going to leave that one to you, Alexey. There is actually a good article, which I'll post whilst Alexey's talking, which has been written by a partner called Casper Gunia, on the comparison of the two, so I'll post that as well. But yeah, the comparison.
Yeah, so basically, as Matt said, none of the tools that were mentioned are databases. So, and in my practice, I've seen a lot of cases when people use the tool they're familiar with, or it's immensely popular for some reason, as something else. For example, I've seen many cases when SQL Service uses a queue. It's pretty easy to do. You create a table, call it a queue, and shovel JSON or XML objects in there and call them messages. And then you have some somewhat complicated processing if you want to support publish subscribe. But if you just want to have a simple queue, then you can use that. And Service Bus even have a transport for SQL Server for situations when people cannot go around and use something else, and all they have is basically use SQL Server. So, and I use in Service Bus SQL Server Transport myself, because we had a situation when the only port we were allowed to talk through was the SQL Server 14.3, and here we go. There is a decent library called SQL Stream Store for .NET that built by Damien and others, colleague of ours, that was born not because they don't like EventStoreDB, but because they had no choice, because they were limited by constraints of their customers that, by governance reasons, cannot use anything else in relation to database. However, if you choose a tool that does the job best, then you need to look deeper. So Kafka is the event streaming. Basically, it was born like a append-only logging system as such. And it remains like that until today, with some additions like Kafka streaming. So Kafka streaming, what does it do for you? It's basically allow you, well, they have a feature of compacted topic, basically representing the current state of a topic as some sort of object, JSON, or whatever you call it. And you can execute a function there, so it will create compacted topic for you. Some people call this as the event sourcing. What we meant by event sourcing, that's what Greg meant by event sourcing, is that you always use a collection of events as a source of truth for one particular entity. And Event Store allows you to do that. So we call it aggregator entity stream that has a name and ID for that particular entity. You read events, all of them, or a subset of those events, to recover the state of your entity. Kafka has no way to do that, because you have one gigantic stream that is called a partition. So basically all this, we have one partition. That's one of the probably weak point of EventStoreDB, that we have one global ordered collection of events All of them come in sequence. And Kafka is able to split them into partitions. By no means topic can represent something similar that's to EventStoreDB streams, because you cannot read from topic as such and reconstruct your things using events read from the topic. So yeah, you can use Kafka as a message broker, if you will, but it's hard to do because basically the only thing you have is publish subscribe. You can use EventStore as a message broker, but I wouldn't recommend so because there are decent message brokers out there that do the job much better than we do. But if you need event sourcing oriented database, probably EventStore is one of the best choices. In my practice, we often combine different tools. So in the organization I mentioned, we use Kafka, we use RabbitMQ, and we use EventStoreDB, and MongoDB, and Redis, and SQL Server, and Postgres, and whatever else we find suitable to do the particular piece of job. And for event sourcing, we use EventStoreDB because that's what it does best.
I'd say that was a fair assessment. I've also linked to the article that Casper has produced recently. Actually, there's also a good article from Axon comparing themselves to Kafka. It's also relevant to the argument.
The question comes to complement this: can pinned persistent subscriptions in EventStore be compared to partitioned Kafka topics? I'd say they're mostly not really, because if you partition the topic, you use a partition key. Well, yeah, we'll partition that as well. What would you say about this, Matt?
Don't ask me on this one, I'm afraid. I mean, persistent subscriptions are great for lightweight scenarios where you've only got a number of consumers. I would argue, though, for larger infrastructures that, yeah, you want to offload this to things like Kafka. But as the comparison between the two, I couldn't honestly tell you. I don't know enough about Kafka. So
yeah, I would say it cannot be compared, because Kafka has a fixed set of partitions, which changing the set of review partition in Kafka is a hard job. It's basically could be a day's job. And when you repartition Kafka, then all your partitioning is like you have 5 partitions, you have a consumer group, and you have 1 consumer per partition for that particular topic. And then you apparently repartition them to have 10. You have to have 10 consumers. And the set of events, or for set of entities or whatever, identified by ID that is used as a partition key, was unique for that consumer and the consumer group. As soon as you repartition that, it will all change, because it will apply the partition algorithm again, and the partitions would never. One of the big issues basically with Kafka and partitions. So you really need to architect Kafka partitions and choose the key properly. And still persistent subscriptions, even with consumers, we don't really care. If you have 2 consumers today and you have 25 tomorrow, we just send them. We do our best to kind of send similar stuff to the existing number of consumers. If you spin up more consumers, we will repartition them on the fly and start distributing the load equally across them. So the pinned strategy only says that we try our best to kind of send events for the same entity to the same consumer as soon as the number of consumers doesn't change. But that's all it does. And if the master or leader node is a new version changes, probably the whole thing starts again and will rebalance from scratch. So I wouldn't really trust it. It's still best effort, and we mentioned this explicitly in documentation. So I would still not try to use it as any sort of guarantee of ordering or whatever, and equal distribution. Equal distribution is actually guaranteed, but not anything else.
Thanks. That is exactly what my analysis about the issue, but it's great to hear it confirming our opinions. Cool. All right. I've got 2 more questions that I want to pick out. The first one is around encryption. And does EventStoreDB have any support for encryption at rest and encrypting P2 in the event stream? So encrypting personal data, I assume. Regarding encrypting personal data, it's also become a big thing recently with GDPR. There are no solutions built into EventStore specifically for handling it, but there are a number of techniques that you can use, such as crypto shredding, which is the idea that all personal information on a given event is encrypted with a given key. And if for whatever reason that information needs to be forgotten, then you can just delete the key and that information will no longer be decryptable. That seems to be the more common pattern for this at the moment. There is also a possibility that you don't actually store the personal information in the stream at all, and just store links to that information in another store, such as SQL Server, where you can then delete the personal information. And another option I've seen chosen is that actually, and I don't particularly like this, but I've seen it done, which is where the personal information is separated into a different stream, and you can delete the entire stream. But that's, I've not tried it myself, but I've seen that talked about in the past. But
I like that one.
Pardon?
I like that one.
Okay.
Because it gives you separation concern as well. So, and it gives you a good indication, because I recently discovered in the production system there was any names of people they want to build a read model. And what I found, they shouldn't have done this, because this information is easily accessible from other read model. They can just reach out to that, and it would make the whole system much easier, because there was a whole sequence of events distributing this information that got really out of control. And after doing some analysis triggered by GDPR concerns, we figured out we can greatly simplify the system by not doing what they've done. So yeah.
I've not tried that in the past. I've only ever done the crypto shredding. We are actually going to publish an article on that, actually giving some examples of how to do that in C#. But yeah, there's another couple of options there. And as far as actually, does it support encryption at rest? I mean, there's no inherent encryption with EventStoreDB itself, but I mean, is there any options you can think of around that, Alexey?
Yeah, basically, EventStoreDB writes chunk files on disk manner. So just piggyback on this for performance reasons. Something I didn't know before I joined EventStore, that you need, for performance reasons, the best thing you can do is basically use one volume for database and another volume for indices, which is rarely done. And in our default configuration, we create index folder directly in the database folder, which isn't exactly great. In the documentation, you can find more words about how the indexing works and recommendations about performance using different volumes. So if you use native file system encryption, then of course it won't solve encryption trust as it should, because it doesn't guarantee that only the database will be able to use that. But a decent degree of isolation of your infrastructure, only when physically getting access to the data to read the content of the file system, and therefore the encrypted disk will be safe to lose in this terms to someone malicious party, because they won't be able to read anything from it. It's not exactly encryption trust, but this is the way you can do stuff. It might have impact on performance, but I think disk encryption in Linux is quite decent. So, and I have it, my Linux machine even asked me on desktop, like, do you want to encrypt the disk by default? So I assume it's pretty safe. But I don't think we are in any way certified to support scenarios when there is a government or regulatory requirements to have encryption trust. We don't have that, unfortunately.
Okay, it's 4 minutes to go, so I'll ask one last question, which is, again, quite an open-ended one, but we'll see what happens, which is how to get started on the event sourcing pattern in an existing big monolithic application.
Oh, okay, let's use 4 minutes to that.
Yeah, I mean, I can speak of it from not necessarily the best approach, but the approach we used when we were implementing event sourcing at the NHS, which was, we were in a very awkward situation, which we had it wasn't necessarily a big monolithic application, it was a big monolithic database with lots and lots of applications individually writing to it. Some that we didn't even know about, because it's the NHS and they've got lots and lots of development teams and not necessarily the best practices. One of the ways we integrated, because we had to listen to effectively the changes in the database in our system, but we wanted it to be event sourced, was to use database triggers. And effectively, the pattern we ended up using was whenever a row was updated in a SQL database, we would generate an event from that change. And then depending upon the information that was changed in that row, we could deduce what sort of event had happened and produce an actual domain event from it. So that was one way we kind of integrated with big monolithic systems. It wasn't necessarily the prettiest, but it did work, and there wasn't much other alternatives at the time. I don't know if you've got any more experience on this, Alexey.
Yeah, quite a lot actually, because as usual, I have dealt with big monolithic systems because everyone has one, except of companies that start today, and they will end up in big monolithic systems in a couple of months anyway. So my take on that yes, we do use triggers quite successfully for a while. We, however, encounter several critical situations when intentionally or unintentionally trigger was disabled and we stop receiving events. And when we start receiving events, the state of our event source application was inconsistent because the events were apparently lost, because you couldn't restart a trigger from the point it was stopped. You started from now. I still don't know who turned off the trigger. I wanted to find out. I had a suspicion it was me, but I'm not sure. Usually disabling the trigger is done before you doing the database migration. And the system that writes the database is supposed to be stopped, but there is no guarantee that this happens. And the DBA doesn't forget to enable the trigger again, unless the whole thing is automated to oblivion. So the risk is big because that leads to direct inconsistency. So how we solve that problem? We basically stopped producing domain events from triggers. What we have done is start producing database events. It doesn't use awesome features that some databases provide with a change of slow. So SQL Server 2017 has this, and I believe Postgres has something similar. So what happens is then you record changes in the database and you produce database event in form like the row in that table has changed, and this is the old data, new data, and I think change of slow doesn't give you the old data, just gives you new. Nevertheless, you keep a certain copy of things on your side, either by replicating the whole table or using a different store, even maybe the state of your system, and figure out what changed since the last known state update that you know about. And then you reasonably being disabled because the next update brings us to the consistent state again. So this strategy is reasonably safe. You can also have fallback scenarios by rereading the whole bloody table again and trying to figure out if you have a copy, then you can always compare and find differences and then issue any missing events. However, we got performance implications because what trigger does, it becomes part of the transaction. So when you start to update the table, the trigger needs to update not the table where you put your database events or domain events, whatever. And for that, when you select with delete from the queue of events, you essentially log that table with updates. And by doing so, you log the main transactional table. So you can't insert for this amount of time. And if you have high throughput transactions on that table, you start to hurt performance by reading from the queue and deleting events from it at the same time. So that's what we have now. But we have a table that receives 1 million records per day, which is not big, but not small. If it goes beyond that, the issue would become even more apparent. So with change upstreams, it's much easier because basically they a bit differently. I think they deduce from transaction log or something like that. So they done asynchronously, but it's still reliably. So transaction log is an integral part of ACID's compliance of the database. So therefore, transaction log is always being written in transactional manner. They would just find it records in transaction log afterwards and put it in change-ups log so you get it properly. That's much better in terms of performance. That's how Kafka SQL Server connector is working, I believe. One from a company called Bizarre. I don't remember. Bizarre name. But if we look in general how you start doing that, just forget about SQL database or whatever. You usually have one, but still, imagine you have a monolithic application. And we had this before on one of the previous webinars. I was showing how to change the persistence from a system that's not event source, that uses state-based persistence. Like I have an abstraction of the aggregate store that says, give me the aggregate and put it on the database. Call me with the ID and I give it the aggregate back. And I was showing how relatively easy it is to move from that state-based persistence by replacing the aggregate store implementation towards event source system. And someone said, yeah, that's rubbish, because if you have a CRUD system, then you can't do that because you don't have your aggregates. So I would say start with domain model. So if you have a domain model, you can use the pattern from Eric Evans' white paper called, what's it called? Bubble context, an autonomous bubble context. So basically you build a domain model and you have your repository, but the repository doesn't have its own persistence, like going to a new nice data model or state model or event sourcing, whatever, that represents your domain model in the best way. You probably end up in repositories that are gigantic ACL that goes in the wiki database monolithic thing that you have and fetches the data you need to reconstruct your aggregate and saves it back. You will spend a lot of time in doing these ACLs, that's for sure. But you have your domain model. As soon as you isolate the domain model and it starts to represent the source of truth, you build an API on top of that and redirect some or all of the calls that were previously updated in that piece of information in your old system to your API. So force them, to, instead of calling database, hunt them down, say, I build the API for you, call my API, I control all the operations there. As soon as you guarantee that all the operations there, or at least start with some of the operations, of course, it needs to happen gradually over time, you get more and more control. So all the state updates that concern that set of entities, that's kind of fuzzy and liquid bounded context that you haven't built in the old system yet, but they're starting to build. So then you can break the line. So instead of persisting it there, you build your own persistence. And here is a perfect time when you do event sourcing, because most of the time you need to keep updating the old system because there's shit on, sorry, there are a lot of some functionality that is still being used in different reports. Like Matt said, nobody knows who is doing that. Of course, you need to hunt down the writes, but usually the number of writes is significantly less than the number of reads. Hunting down all the reads is a hell hard job. So when you hunt down the writes and turn it over to your API, you can still facilitate the reads by using event sourcing quite easily because it just becomes a read model. Gradually, in time, another team is starting to do the same with another piece of that system and build their own domain model. And they become autonomous and independent, and they convert SQL as from a source of truth, or this monolithic database from source of truth to a read model. And this is where I see a lot of potential. So basically, at one day, say, okay, my source of truth is my system. I either use repository directly to reach out to SQL Server or whatever database I have, use a trigger strategy to update the state of the system, but still I consider I need to kind of adopt or comply with what they tell me. At some point you stop to comply when you start controlling all the updates. You can cut the line, you don't care anymore what they tell you, kill the bloody trigger, kill your old repository if you have one, and build a projection that will push data back, because you are the master now. And that's a great pattern, and it's very successful.
Sounds good.
The nastiest part is then when you start going, I mean, it's good if you have all your updates in stored procedures. So you can just search your source code. It's good that your database is in source control, because I've seen companies that claim to be quite good in doing what they do, but the database is not in source control. So if you plan to do that and your database is not source control, start bringing your database source control. It will save you one day anyway. If you succeed or not to build any event source application, that's a good thing to do.
Yeah.
And then you can search. You search your table names, procedures, whatever in source control, and find all the updates, and off you go. I think Greg in his class has the case of failed CQRS system that he promotes the idea that the state transitions are represented in a table that is basically a ledger, and updating it to the same transaction because you have transactions there. You don't read from it unless you need to. And essentially at one day you just hidden by doing some dirty trick, replace it with EventStoreDB and kill that table. Nobody knows about it anymore. And this third level normalized database becomes readable. He talks about the same pattern essentially, but he introduced intermediate step to keep your DBA happy.
So that wasn't a 5-minute answer.
Yeah.
You mentioned then that you wanna answer one last question we got asked in the
Yes. One question came in the Q&A from Javier. Any guidance implementing exactly one's delivery strategies for competing consumers? I've done it myself, but I wanted to have your input. Dealing with distributed systems for quite a while and pretty large scale, I could say that exactly one's delivery doesn't exist. For a very simple reason. Let's say your consumer fails and you have to do the retry. So you have to deliver twice. So what you have to take care of that your consumers are important in terms of they, for example, don't do two-phase commits. Or they have to use distributed transaction coordinator or something like that to ensure that what you do inside a consumer is transactional. If you have only one database to work with, it's pretty easy. If you all the patterns that guarantee things like that, like transactional outbox in a service bus,
yeah,
they rely on underlying transactional store. They assume that the updated execute uses the same store, and their intermediate place where they persist events or commands that need to be sent over the message broker will be put there first. They can be wrapped into the same transaction. That's not all databases can do that. Just remember this. So because they target mostly Microsoft customers that mostly use SQL Server, it's safe to say you can do it unless you have two databases. Then you're screwed. So with our competing consumers, it's pretty decent to say that we guarantee no less exactly one's delivery than, for example, Kafka or Event Hub or whatever else in that regard. Because what we don't have is the problem of RabbitMQ that comes to a partition state in the cluster, and suddenly after the cluster recovers, it says, okay, oh, look, I have an event, I need to send it. But it was sent by another node at the moment the cluster didn't know about its current state. So this problem we don't have. So it's possible to mitigate the things by keeping, for example, a collection of event IDs that you have already processed before, keeping versions and stuff like that. So it depends on what you consume and what you do in a consumer, because there are a bunch of things you can do inside a consumer to guarantee not the delivery, the processing. So I would say I would focus more on idempotency of my consumer,
yeah,
instead of trying to achieve exact one's delivery from the infrastructure, because suddenly you decide to change from, for example, you move to the cloud, you use the broker, RabbitMQ, you want to use managed service, you go to Google PubSub, and suddenly you want to rebuild the whole bloody thing because they stopped delivering you this guarantee. I would do that. I would say, I want my consumer to be idempotent. I'm writing specific unit tests to check if this is the case.
I mean, using a deterministic ID approach as well. I mean, that relies on a number of things. I mean, how many IDs are you gonna start to check against? How long does it take to?
Yeah. So basically, Javier says it cannot be implemented on the server. It's impossible. That's true. So it has to be handled on the receiver, generating some sort of deterministic identity that has to be recorded. Yes, that's right. That's what I'm saying. So you can keep the collection of IDs, or even collection. If you don't have deterministic ID, you can keep events or commands, whatever messages you processed in the consumer. So the risk would be if a consumer goes down, if you all kept in memory, you lose this collection, you can't compare it. But you can use value object quality by value instead of quality by ID. But most of the brokers and whatever else users still put ID on any message, including EventStoreDB. So they all have IDs. This is not the ID that we generate. This is the ID that you have to give us, and it must be unique. And then we give it to you. So you can do it. And that's very common in ensuring dependency and read models when there is no other way that can help you. You just put a rolling list of last events that you projected. And then you can always compare if my event is there, so don't project it again. And then you probably can do something interesting things like projecting events out of order and stuff like that, but it's a bit more tricky.
We actually do that within inside EventStoreDB itself. But I mean, how many IDs do you store?
It depends.
Yeah, I know. So I mean, you know, if you only store 10, but you're processing 100 a second,
yeah.
you know, it's.
I can give you an example. So we built event store system with actor model, and it's responsibility of actors to keep the list of IDs or list of even messages that because we didn't have message ID that's guaranteed. And even worse, what we got not guaranteed exactly once delivery because the message could have been sent twice by the sender, but the content of the message would be exactly the same. We should have ignored it because it's a duplicate message.
Two separate IDs.
So two separate IDs.
Yeah.
So we compare them by value. All of these messages are deserialized value objects, and ignoring the ID, we can compare the ID, but we just didn't find it's saving a few nanoseconds of CPU cycles. We keep, but the life cycle of the entity is pretty short in terms of that it's either actively receiving messages or it considers complete. It considers itself complete and then it stores and probably never changes. And then the whole issue of receiving events more than once disappears. During that active life cycle, it keeps a copy of all the messages inside the actors. Actors is pretty easy because you have a state which you can or choose to persist. And then it becomes obvious. Basically, you ignore all duplicate messages, comparing them by value and dropping them on the floor.
Yeah. So
this is a bit more advanced, but we find it very useful because of the nature of the business that we could receive the same message several times because when the device is sending the message, it sent the message, but it didn't get an ACK, consider it unsent, but it was still sent. So it tries again and it sends a new message through the MQTT broker with assigned a new ID to that because our devices were not able to assign the ID. Now our new devices can assign the ID, then it makes our life easier. But still, a lot of things can happen in an interconnected world, especially if you don't have reliable connectivity. And by definition of distributed systems, network is never reliable. So
no, I think when it comes down to it, trying to make your handlers as idempotent as possible is a safe bet on most of this stuff, right?
Yeah. And of course, the strategies very much depend on what is throughput. So if your throughput is low, you probably keep 5 and then you call it a day and you don't care anymore.
Yeah. We've run 15 minutes over, so I think we're probably going to call it there. We got asked a lot more questions than we've answered, so I think it's likely that we'll probably try and run another one of these in maybe a month or so. Either ask the remaining questions or any more that have been asked since.
And I think we got a decent interest in the company from people that want to share the knowledge, but they don't want to prepare the talk, but they are pretty happy to answer questions real time.
Yeah.
So James Gill, Chris Cotton, and someone else, Zach maybe even.
Yeah, I think this one's we focus a little bit more on kind of event sourcing questions. I think if it's potential, the next one, if we speak to Zach, we might do one specific around the cloud.
The cloud,
plans are for that because I know we're getting a lot of questions about our cloud platform, which is coming out soon. And equally, if we do one with James Gill, who's the VP of Engineering, we can probably ask more specific questions about the internal operations of EventStore, which I think will also be of interest. So we'll try and organize those over the coming months. So, but
so once more, just to say, Matt put the host name, not the URL of the documentation website. So we will publish a link soon on the old docs. It will be a banner on the top saying this documentation obsolete. So please look at the new one.
Yep.
So the new one is not less complete than the old one. So it exceeds the old one in all ways, by all means. But excuse us. So there is a disclaimer and the big button, and I wrote the text for it saying, I understand that's not complete and I won't complain much, but we appreciate the feedback, which is constructive, saying, okay, this is missing, this is confusing and stuff like that. So we do all the editorial ourselves. So English is not my native language, but sometimes I need to correct Matt text and he corrects mine. So if you want to take part of the editorial process and make fix silly mistakes, by all means, you're welcome. We will soon make the repository public. It's now private, so you couldn't submit issues and pull requests just as today, but it will be possible soon.
Somebody's saying we're getting a 404 and I'm not getting a 404. I don't know if they're trolling me or not.
I don't know.
Okay, I'll check it out.
It's work in progress, so...
Yeah. If it's getting a 404, I'll fix it, but I'm not currently getting a 404 on mine, so I'll have a look at it.
Yeah, it works on my machine, so...
Yeah. So get up. All right, thank you, everybody who's attended. It's been appreciated. I hope some of the answers have been insightful, if nothing else. And like we say, we'll try and organize another one of these for maybe a month's time, potentially with somebody else to give Alexey a break.
Yeah.
All right, thanks very much.
Thank you very much, everyone. Yeah, all right. Have a good evening.
Yep,
Bye-bye.